Dear students, welcome to the class of business mathematics. In this video, I will discuss matrix definition and several types of matrices. So, the first of all, how can we define a matrix, or what is a matrix? A matrix is a rectangular array of numbers or rectangular arrangement of numbers. Any rectangular arrangement of numbers is called a matrix. Any rectangular array or arrangement of numbers like this, let's say 2 5 6 7 9 8 2 9 5 2 3 4. So this is called rectangular arrangement of numbers enclosed within either first bracket or third bracket is said to be a matrix. If this element is missing here, suppose there is no 3, then the arrangement is not a rectangular arrangement. In that case, the arrangement will be an octal arrangement. You see, like this. The arrangement is said to be an octal arrangement. 1 2 3 4 5 6 7 8. So this arrangement now is an octal arrangement. However, if you put 3 here or any other number, then it will be a rectangular arrangement having 4 units of length and 3 units of width. So it is a rectangle, and if we can arrange some numbers in rectangular form, then enclosed within either first bracket or third bracket, then it is called a matrix. For example, 1 2 3 4 5 6. This arrangement is called a rectangular arrangement. It has 3 units length and 2 units width. So it is a matrix. And in other way, you can say a rectangular arrangement of numbers. Numbers can be real or complex in rows and columns is called a matrix. Then how we denote a matrix? Matrices are denoted by English block letters. For example, A, B, C and so on. Let us put a name for this matrix by English block letters A. So A is a matrix having how many rows? These are called rows, this one and this one. So it has 2 rows and how many columns? First column, second column, 3 column. And this indicates the number of rows and columns indicates order of a matrix. You need to put this order here, 2 by 3. You should read as 2 by 3, but write as 2 cross 3. Here 2 indicates number of rows and 3 indicates number of columns. Let us consider this matrix. It has how many rows? And this is called the general form of a matrix having m rows and n columns. You see, this is the first row, and this entry, where is the position of this entry? First row, first column. And the position of this entry, first row, second column, first row, zth column, and first row, nth column. So there are n column, and how many rows? 1 2 ith rows is this one. This is second row, this is first row, and this is mth row. So I need to put m here. And this matrix A has how many rows? M rows and n columns. So this is called a matrix of order m by n. This is called order of this matrix or dimension or size. Order or dimension dimension or size of this matrix. So the order of this matrix is m by n, or dimension of this matrix m by n, or size of this matrix m by n. This matrix we can also write simply in this way: A equal Aij, where if you put m by n, it indicates I is from 1 to m and j is from 1 to n. Like I said, any rectangular array enclosed within either brackets or parentheses or a pair of double bars is called a matrix. So here you can see two examples. A and B are two matrices. They are of how many rows? 2 rows and 3 columns. So A is a matrix of matrix of order 2 by 3 or dimension 2 by 3, and another matrix B is of again order 2 by 3 or dimension 2 by 3. Now let me discuss types of matrices. There are several types of matrices. I will discuss here some important types. For example, two matrices are said to be equal when they are of same order and the corresponding entries of two matrices are same. For example, if A and B are equal, then we can say A equal to 1, B equals -1, D equal 3, and E equal 2. And they are equal because they are of same order. A is of order 2 by 2 and B is of order 2 by 2. Their corresponding entries will be equal when they are equal matrix. Second, square matrix. Square, what is a square? We know a quadrilateral is said to be a square when it has equal sides. So here a matrix is said to be a square matrix when it has equal number of rows and columns. When a matrix has equal number of rows and columns is called a square matrix. An m by n matrix is said to be a square matrix when m equal to n. For example, this matrix is of order 2 by 2, so it is a square matrix. The second one is of order 3 by 3, this is a square matrix, and the third one is of order n by n, so this is a square matrix. And this is another example of a square matrix. It has 3 rows and 3 columns, so it is a square matrix. Now the row and column matrix. Row matrix. A matrix is said to be a row matrix when it has a single row. For example, this one, you see it has 1 row and 3 columns. 1 row and how many columns? Column 1, column 2 and column 3, but a single row. So it is a row matrix. And a matrix having single column is called a column matrix. For example, it has single column, 1 column, 2 rows. The order of this matrix is 2 by 1, so it is a 2 by 1 matrix or column matrix, or sometimes it is called column vector, row vector. Row matrix is also said to be a row vector. Then null matrix. A matrix which has every element is 0. A matrix in which every element is 0 is called a zero matrix. যে ম্যাট্রিক্সের সকল উপাদানের শূন্য সেটাকে আমরা বলি শূন্য ম্যাট্রিক্স. হোয়াট এভার দ্য অর্ডার ইজ, অর্ডার যাই হোক না কেন, it will be a zero matrix. And diagonal matrix, when all non-diagonal entries are 0, then it is called diagonal matrix. For example, you see these are the diagonal entries. This is called principal diagonal or main diagonal of a matrix. So a square matrix, it must be a square matrix first, then it will be a diagonal matrix when non-diagonal entries are 0. So you see the non-diagonal entries are 0, but diagonal entries are a1 1, a2 2, a3 3. So it is a diagonal matrix. And again a scalar matrix. When a diagonal matrix is said to be a scalar matrix when all of its diagonal entries are equal. A diagonal matrix, let me say it again, a diagonal matrix is said to be a scalar matrix when all of its non-diagonal entries are equal. For example, A is a scalar matrix since all diagonal entries are A. Now identity matrix. When all diagonal entries are 1, a diagonal matrix is said to be an identity matrix or unit matrix when all diagonal entries are 1. You see, this need to be a diagonal matrix first. Then if all diagonal entries are 1, then it is called a unit matrix, and it is denoted by in, where n is the order of this matrix. I2 means it will be a 2 by 2 matrix. I3 means it will be a 3 by 3 unit matrix or identity matrix. Then transpose of a matrix. A matrix which is obtained from a given matrix by interchanging its rows and columns is called a transpose matrix or transpose of A. When the given matrix is A and you interchange its rows and column, you will get its transpose, and it is denoted by either a to the power small t or a to the power capital T. For example, A is a given matrix and this is the first row. Now in A transpose, 2 1 will be the first column. The second row 3 2, in A transpose 3 2 will be the second column, and 4 5 is the third row. 4 5 will be the third column in the transpose. And then symmetric matrix. Symmetric matrix, a matrix A is said to be symmetric if A and its transpose is equal. If A equal A its transpose, a matrix A is said to be symmetric if A and its transpose will be equal. In other words, a matrix is said to be symmetric if it is a square matrix and Aij equal Aji, which means A equal A transpose. For example, this is a symmetric matrix because you see A1 2 is equal A2 1, and this is another symmetric matrix. You should note that it will be symmetric when this component and this component will be same, and this component its position 1 3 and the position of this component 3 1. So these components need to be same, and the component this one and this one should be same because the position of this one is 2 3 and this one 3 2. Whatever the diagonal entries, it is not a problem. Let me write another example here. A equal 1 2 5, so I should put 2 here, 9 7, and since in this position I have 5, so I should put 5 here, 5 7 8. This is a symmetric matrix because A transpose will be exactly this one. You see the first row 1 2 5. Let me write first column 1 2 5 in the A transpose. 2 9 7 will be the second column, in A transpose, and 5, 7, 8 will be the third column in A transpose. Now you can see A and A transpose, they are equal, so it is a symmetric matrix. And the next one is skew symmetric. A square matrix is said to be skew symmetric when A equal negative A transpose. When A equal negative A transpose, then A is said to be skew symmetric. So what should I change here? In that case, to make A and negative A transpose equal, all diagonal entries should be 0. This one should be 0, and corresponding one of 2 and this 2 should be opposite sign. If this one is positive 2, this entry should be negative 2. If this one is positive 5, this one should be negative 5. If this one is positive 7, this one should be negative 7. Now you see A transpose will be what? 0, 2, minus 5. 0, 2, minus 5 will be the first column. Minus 2, 0, 7. Minus 2, 0, 7. And 5, minus 7, 0. 5, minus 7, 0. And if you now take minus outside of this matrix, you will get 0, 2, minus 5, minus 2, 0, 7, and 5, minus 7, 0. So it is nothing but A minus A. You see, A transpose is equal negative A, or I can say A equal negative A transpose. So A is called skew symmetric. Here you can see other 2 examples of skew symmetric matrix. Now submatrix. Submatrix is a part of a given matrix. For example, let's say you are given this matrix, and the submatrix of this one will be this one. You take 1, 2, 3, 4. 1, 2, 3, 4 is this one. If you can delete first row, first column, then you will get this one. This one is submatrix. You can delete second row, second column, first row, you will get 1, 2, 7, 4. It will be a submatrix. Now the next one, upper triangular matrix. Upper triangular matrix and lower triangular matrix. You see, a upper triangular matrix is a square matrix in which all the elements below the principal diagonal are 0. Then it is upper triangular matrix. For example, in this matrix, you see, this is the principal diagonal, and all entries below the principal diagonal are 0. So this is a upper triangular matrix. Let me put another example here. 1, 2, 5, 0, 7, 9, 0, 0, 8. This is a upper triangular matrix because all entries including principal diagonal, all entries below the principal diagonal are 0. So this is UT matrix or upper triangular matrix. Again, the lower triangular matrix will be what? If all entries above the principal diagonal, you see 1, 0, 0, 2, 5, 0, 7, 8, 9. This is a lower triangular matrix because all entries above the principal diagonal are 0. So this is a lower triangular matrix. I hope you understand. You can see another example. Here also all entries above the principal diagonal are 0. So this is a LT or lower triangular matrix, and this one is UT or upper triangular matrix. And the next example, next type, let me say another one, which is singular matrix. A matrix is a square matrix is said to be a singular matrix if its determinant equal to 0. Let me say it again. A square matrix A is said to be singular if its determinant is 0 and non-singular. A square matrix A is said to be non-singular matrix if the determinant of A is not equal to 0. For example, let's say A is like this, 5, 7, 2, 3, and we know determinant of A is equal 5 into 3, 15, minus 7 into 2, 14, which is 1, which is not 0. However, this A, let's say 1, 2, or 3, 2, 9, 6. Determinant of A here is equal 3 into 6, which is 18, minus 9 into 2, which is also 18, equal 0. So this A is a singular matrix. And the determinant I already discussed in another lecture, where I explain solving system of linear equation by Cramer's rule. In that lecture I discuss determinant, how can we calculate determinant of a 3 by 3 matrix. You can have a look on that lecture to understand determinant more clearly. So that's all about several types of matrices. In my next lecture I will discuss algebra of matrices. Thank you very much for your watching.